So we can square it and times it by m and times it by 1/2, and we got the kinetic energy.
In other words, you've got the mass, you know the velocity, so you can get the expression for the kinetic energy, right?
Right.
Okay?
No.
You can.
Stop.
You do. I don't. Well, it's not really delta. It's the same. It's going the same place, so it doesn't matter. Same directions. So you can use that.
And we've got to multiply that by our expression for V exit, which is cross-sectional area over exit area. Right?
Right.
And then that's times velocity of the layer. So is that what we want to do?
Hey, that's rough. That's getting rough.
Huh?
So that's getting rough.
It's getting rough, but you probably should have used a different expression for V exit.
Oh, we had Vx is square root 2gy.
Yeah.
Yay.
So instead, because we established that V exit was this, right?
Right.
So what we had here was just an intermediate,
Brain fart.
Well,
okay?
I was thinking two finance videos.
Oh, yeah, all right.
Yeah, I'm on some of
Yeah,
this.
that's what it is.
Yeah.
Feels like we never left.
We did. It was only like 3 weeks.
And we're going to get a 2gy here. So this 1/2 can go away.
Two.
Here we have this expression for the change in its kinetic energy, right?
Well, it's not, it's a heat.
So what's the force?
Rho times A exit times gravity times y.
Yeah, because we have this. Now, well, let's see now. Provided F is parallel to delta x, then your F delta x,
Same direction.
F dot delta x is just F times delta x, right?
Right.
And we haven't necessarily established that, but we have F delta x equal to rho delta x A exit gy, so that F equals rho A exit gy. Okay? Now, you know what pressure is? Well, you just had plenty of it at the end of last semester.
Yeah.
Okay, well, that's the universal experience of students who either for one reason or another, procrastination, overwork, or just general sorriness, don't get everything done. I don't suspect any of you guys of general sorriness. Procrastination maybe happens a little bit, but I think it's mainly a difficulty in balancing everything, right?
I like that really. I think it's-
Now I digress, that's not the pressure we want to talk about. Okay, the pressure we want to talk about here,
I wish we had like,
what do you mean by, how do you measure tire pressure, what units?
ATL,
In what?
atmosphere.
And how many atmospheres do you put in your tire?
Pound square inch?
Yeah, you usually do it in pounds per square inch, right?
Yeah.
Now, if we want to do it in metric units, what are we going to use instead of pounds?
Pascals.
How many pascals are there in a pound?
I say there's atmospheric pressure,
I
man.
don't know.
Yes, we are going to use pascals. We're trying to figure out what a pascal is. Okay, so instead of pounds, what does pound measure? It's a unit of
Force.
force. What's the unit of force in SI? Yeah, newtons. Okay, and square inch. What's inch a measure of?
Length.
Length. Okay, what's the unit of length that we use? Meters. So instead of pounds per square inch, we're going to use newtons per square meter. Anybody know what that's called? Lane does. He just said it, it's a pascal. Okay? Now, we'll say a little bit more about pressure.
I like my answer.
Oh, what did you say? Atmospheres, yeah.
It's force per unit area. You here for the applied calculus?
I am.
Oh, come on in, have a seat somewhere. We'll get started in about 5 minutes. I guess this means we're almost out of class time, doesn't it?
I think so.
I don't even know what time we were supposed
Yeah,
to.
I was thinking. We were on 55 minutes, 50 minutes of class, 5 minutes of break. Okay, so that's not surprising. Oh, phooey.